I don't feel particularly prepared to energize myself a little bit.
Yeah, I know. I can feel that you're getting into Matt.
Yes, I'm stepping into the persona
Yeah.
of Matt, and I'm
Yeah.
not doing a great job so far. Hi, I'm Matt.
Hi, I'm John.
In today's video, we're continuing our series discussing cybersecurity for large language models. Last week, John wrote a fantastic blog on membership inference attacks, and we're going to be talking a little bit about what they are and how they work. So I suppose that's the starting point, John. What is a membership inference attack?
So yeah, in its simplest form, you have a data sample and you have access to a model. And the goal is basically to determine whether that data sample was used in the model's training data set, because it gives you some knowledge about how that model works and how it's been trained.
Okay, so you can figure out maybe like personally identifiable information and things like that by doing this, right?
Yeah, exactly. There's models out there that have been trained on data from the internet that contains sensitive information. This is one way to reveal that information.
And I heard there's been some particularly high profile examples of people doing this.
Yep. So ChatGPT is a very popular proprietary model, and ByteDance, the parent company of TikTok, have been running this attack to try and create their own version of ChatGPT.
Right, and that's quite interesting because it touches on another point that I wanted to understand better. It seems like membership inference attacks and model stealing attacks have something in common, but they're not quite the same thing. How are they related?
No, they're slightly different. You can think of membership inference attacks as almost like a child of model stealing that feeds into a model stealing attack. It's one component of what would be a model stealing attack.
Right, but I suppose if you're doing a model stealing attack, you're looking to reconstruct the whole training set. But to do a membership inference attack in isolation would be because you want to target a particular person or something like that.
It's more about trying to understand exactly whether a particular data point was used in training or not. So if you do that multiple times, you can build up a certain amount of certainty that the data set you've got is what's actually being used to train the model.
Right, and hence the name membership inference, because instead of trying to figure out what the data was, we're just trying to figure out, does this exist?
Yeah, exactly. It's also known as a data extraction attack.
So finally, what kinds of techniques might you use to mitigate against this sort of attack?
Yeah, so there's data protection techniques that can be used. One of them is differential privacy. So this would reduce the amount of sensitive information that's contained in your training data. So if someone were to run this attack, the risk to people and individuals is massively reduced.
Right, because when you train the model, you're actually replacing the sensitive data with some other representation. And as a result, the membership inference attack doesn't work, but the model is still effective.
Yeah, so you're replacing the sensitive information with carefully crafted noise.
Yeah.
That still means that you can use that data to effectively train a model without that data being present.
Sure. And that's really cool because differential privacy is something we've been hearing about a lot on and off, but in terms of practical use cases, it's still felt quite nascent until recently.
Yeah, it's becoming a more common technique in,
Sure.
in training LLMs. Yeah.
And if you want to learn more about membership inference attacks, then we'll provide the link to John's full blog. Thanks as always for watching, and we'll see you in the next one. Bye-bye.
Bye.
That'll do.
Yeah, that's spot on.